Hello, welcome to today's video, which is going to be about Introduction to KiCAD. And in this workshop, we're pretty much going to be introduced to the basics of KiCAD as well as design our own PCB to build a simple LED circuit. What is a PCB? PCB stands for printed circuit board and it allows for circuits to be more securely connected together via soldering, and it's foundational to a lot of modern electronic devices. So, for example, medical devices or your laptop. And essentially the way that PCBs work is that you have conductive and insulating layers and it's all sandwiched together. And the conductive and insulating layers essentially combine the different components of the PCB. So for example, if you have like an LED or like a resistor, it would have a connection going between them. So for example, you see like these lines over here. And the way that works is through the different conductive and insulating layers, allowing you to build a variety of different kinds of circuits. So there's two main types of PCB techs. You have THT and SMT. So THT stands for through holes technology. And essentially the way that works is that the PCB has holes up here. So you place the components through the hole and then you solder it together in the back. And then that's essentially how you combine your components together. And then you have surface mount technology, which is more often used just because it's a lot easier to automate this. And the way this works is that you have like these conductive pads over here, and then you solder the component on the pad. So you're not actually like fully drilling through the board, but you still have that connection there to be able to attach things. So there's a lot of different programs you can use to design your own PCBs, but for this workshop, we're going to go over KiCad for a couple of reasons, mainly that it's free and it allows you to design the hardware that goes into manufacturing PCBs. And it comes downloaded with a bunch of tools and libraries, which allows you to do a whole bunch of features, such as drawing up your own schematics, actually designing your PCB, as well as exporting the manufacturing files so that you can take your PCB that you designed on KiCad and send it to a manufacturer and actually get like a physical PCB that you can use in your projects. So now it's part for the workshop demo. So for this, the very first step is that we're going to download KiCad. So the steps for installing KiCad is that when you're on Google, just like Google KiCad download, and then go to the first link, choose whichever operating system you use. I have Windows. It's already installed on mine, so I'm not really gonna like install it again, but I'll just show you where to go. So if you're doing Windows, then you would go to the GitHub one, and then you would click that, and then you would start installing it onto your computer. I forgot to mention, but regardless of which operating system you choose, just download the GitHub one. And then once that's downloaded, just go through the steps of like choosing where you want to put it on your computer, and then just wait for it to finish installing. Now the next thing is that once it's done installing, then we're going to go through the process of building our circuit, which is just going to be a simple LED resistor circuit. So here's an image of the circuit we're going to make today. So the first thing we're going to do is that we're going to open up KiCad on our computer, and then you're going to go to File, New Project, Default KiCad Project Template, and then you can name it whatever you want to name it. I was going to name it Workshop Demo. And then, yeah, so then after that, we're going to go to the Schematic tab, open that up, and then a quick overview is that over here, this is where you're going to go to place the symbols. So since we're going to start building the circuit over here, we're going to go here and start selecting the components that we need. So the first component that we need is a resistor. And then if you select this and you click E, then you can change the value in here. So on the schematic that we have, it says our value is 470, so we're going to change this to be 470. And then click OK. And then same idea with this on our schematic. This is 9 volts, so we're just going to change the value up here to 9. And then our next step is that since we have our components placed, what we want to do is that we want to wire it up. So click Draw Wires, or you could click the shortcut W, and we're going to start connecting it together. Yay, perfect. Our next step is that we're going to want to click the Annotate button, so then each of our components can get numbered. It's helpful if you just click Annotate, and then it says our annotation is complete. So then now what we should see is that all our components should be numbered. And it's helpful if you have a lot of different components to have it just be like numbered, but because we don't have a whole lot in this example, it doesn't make that much of a difference, but just generally it's a good rule of thumb. The next step is that since we have everything numbered, we want to actually check if our circuit can work. So what we do is that we're just going to run the electricals rule checker, and if there's any errors, like such as like our wires not being connected or something like that, it'll let us know now. And it's always good to run this test so that you know sooner rather than later if something's not working with your circuit or if you have any small errors like this. Okay, now that we have our components and we double check to make sure that our circuit shouldn't give us any errors, what we're going to do next is that we're going to go to Tools. We're going to go to Assign Footprints, and it's going to take a minute to load, but once it does, you're going to see that all the components in our circuit shows up here. And what this step is for is that you're assigning a different, like a different output to each aspect of your circuit. So for example, if we make sure you select these two so that it filters it out properly. So for example, if we do battery, for the battery inputs, they have a different kind of footprints that we can have on our PCB depending on the battery we have, or the batteries that we want to use, or just depending on how you want to have your PCB be connected. So a way you can actually like look at all of this is that you can select one you find interesting. You can do view selected footprints, and it's going to show you what it's going to look like on your actual like final PCB board. So that's a way to like know what these mean and what you're wanting to use depending on your final project. So for the sake of this demo, I'm just going to use this one, which would be, yeah. So you're going to use this one, and then you're just going to double click it, and then it's going to assign it to this component. So now we're going to do the same thing with our LED, where we're going to find that LED module, and like we said earlier, it's surface mount versus through hole. Depending on what you're wanting your PCB to look like, I'm just going to do the through hole one, and we're just going to use this one. And then I'm going to do the same idea with the resistor. Okay, so then now that we have our different components assigned, we're going to do apply save schematic and continue, and we're going to click OK. So then the next step is that this is the final step where on the schematic where we're going to export it into a netlist. We're going to save this export netlist, and then we're going to save this onto our computer. Now that we have our circuit already designed and we have our netlist exported onto our files, what we're going to do is that we're going to switch to the PCB editor. Okay, so now that we got to the actual PCB step, what we're going to do now is that we're going to go to File, Import, and we're going to import the netlist that we got in our previous step. So for me, I named it Workshop Demo. So we save it here, load and test, update PCB, and then we're going to close out of it, and then all our components should be here. And what we can do now is that if you like select individually these components, you can like move it around, and you can just rearrange it depending on what you want your board to look like. So I'm just going to do this. And then the next thing we're going to do is that we're going to actually like make the connections onto this board. So right here, we have forward copper, and then you have backwards copper. So if you want your connection line to be on the front of the PCB, you would do forward. But if you want it to be on the back of the PCB, you would do backwards copper. So I'm just going to have all of this be on the forward. And you're going to click this button, and you're just going to start drawing these connections. and it highlights it for you so you can see where you're placing your connection lines. And then I'm just going to do this one in the back. Okay, perfect. Now that we have these connection lines drawn, what we're going to do is that we're going to go to edge cuts. We're going to select this, and we're going to select the draw lines. And essentially this is what's going to draw out the edge of our PCB. So you can make it into whatever shape you want your PCB to look like, depending on where you're attaching it and all that. Okay, now that we have our PCB made, what we're gonna do next is that we can look at it, what it looks like in 3D. So we go to View, 3D Viewer, and yay, we have our PCB here. And as you can see, we have the connection in the back that I was talking about earlier. We have that one in the back, and then we have these connection lines in the front, which we did with this tool. Okay, so that brings us to the end of this workshop. Thank you for watching the video. If you guys have any topics that y'all want us to cover or any specific workshops, please feel free to let us know. And yeah, thank you for watching. Bye.